For question 16.54, we're given the KSP of iron 2 hydroxide, and then we're asked, at what concentration will a 0.4 molar solution of iron 2 plus begin to precipitate iron 2 hydroxide? And this is a good question because it kind of brings together our solubility calculations based on KSP as well as our pH calculations. And so for iron 2 hydroxide, we're looking at the following equilibrium, where iron 2 hydroxide solid will go into solution to generate iron 2 plus and 2 hydroxide. So we want to know the pH when we start to precipitate iron 2 hydroxide under this concentration of iron. The KSP expression would be what is the concentration of iron 2 plus times the concentration of hydroxide squared because of the coefficient 2. I know the KSP is 1.8 times 10 to the minus 15, and I know my concentration of iron is 0.4 molar. What I don't know is my concentration of hydroxide. That's what I need to find, and that's still squared. So divide both sides by 0.4. And I get x squared equals 4.5 times 10 to the minus 15. I'm going to take the square root of both sides to get my value of x is equal to 6.7 times 10 to the minus 8. And what is x, right? X equals my hydroxide concentration. So now I can find the pOH of the solution because we know pOH equals the negative log of my hydroxide concentration. We know pOH would be the negative log of 6.7 times 10 to the minus 8. So the pOH of this solution is pretty close to 7, about 7.17. We want to find the pH. Well, the last relationship we know is pH plus pOH equals 14. So the pH of this solution would equal 14 minus the pOH. So pH equals 14 minus 7.17. The pH of this solution would need to be about 6.83 when we would start to see iron 2 hydroxide precipitate. And it would be pHs above 6.83. If we were at a pH below 6.83, so more acidic pHs, we would actually increase the solubility of iron 2 hydroxide.